Hi, my name is Xing Yang. I work for Huawei. I'm the lead architect on the OpenSDS project, which is an open source project under Linux Foundation. I'm also a co-reviewer in Cinder and Manila since the Juno release. I'm also a contributor in Kubernetes and CSI.
Okay. I'm Zhen Chen, and also worked for Huawei. I contributed on OpenStack, Kubernetes, and Terraform. Thank you. Today, the replication includes 4 parts. First, Xing Yang will introduce CSI comprehensively, and then I will describe the implementation of Kubernetes CSI. After that, Xing Yang will introduce CSI driver implementation based on Cinder. And last, I will show you a demo on how to use CSI driver. Okay.
So what is CSI? CSI is Container Storage Interface. This is an industry standard to design a set of storage interfaces so a storage vendor can just write one plugin and have it work across a range of container orchestration systems. Without CSI, each CO has its own way of writing a plugin. Docker has its plugin, Mesos has its own, Cloud Foundry has something called a Percy for its persistent volume service, and Kubernetes has Flex Volume, Dynamic Provisioner, and the Entry plugin. So with CSI, we have a unified interface, so we can just write one plugin that should work for Kubernetes, Mesos, Docker, and Cloud Foundry. This is a simplified volume lifecycle. So volume first gets created, and then it gets attached to a node. They're mounted on a node, so a container can have access to it. And after that, when the container is done with the volume, it can be unmounted, detached from the node, and then deleted. In CSI, there are some different terminologies. There's a controller publish, that is actually the attach volume operation. And then there's a node publish, that is actually a mount operation. And similarly, there's a node unpublish for unmount, and there's a controller unpublish for detach. So CSI defines a gRPC protocol between a CO and a plugin. There are 3 services: the identity, controller, and node services, which we will go through in detail later on. There are several ways to deploy a CSI plugin. There's this centralized versus headless plugin model, or the split component versus unified plugin model. So the first diagram, that is the centralized plugin model. So we have the controller plugin on the master node, and then we have a node plugin on each worker node. And the figure number 2, 3, and 4, those are our headless plugins. So we don't have a controller plugin on the master node. So everything is on the worker node. And figure number 2, we have a controller plugin and a node plugin. They are separate, so that's a split component model. And number 3, we have the controller node plugin. They are all together in the same plugin. And in number 4, we only have a node plugin. So in this case, the plugin didn't even implement the controller functions. Controller service have RPCs for create volume, delete volume, controller publish, unpublish volume, validate volume capabilities, list volumes, get capacity, controller get capabilities, and create delete snapshot and list snapshots. So controller has capabilities to create delete volume, publish unpublish volume, list volumes, get capacity, and create delete snapshot, list snapshots. Create volume RPC takes a name and the capacity range with the upper and the lower limit, volume capabilities, whether it is a block or mount volume, access mode, parameters, those are opaque field to the CO, but only plugin can understand. And then there's this volume content source field, which is new. That is for the snapshot feature, so you can take a snapshot and then create a volume from that snapshot. And the create delete volume capability, if that is supported, then the plugin must implement that. This is a idempotent call, meaning that if you give the same name, capacity, and other parameters, you should get the same results. So if the volume is already created, then you should just get a success. Also, it's a synchronous call, so it will be blocking until it comes back. In the controller publish volume, basically this one takes the volume ID and node ID and basically does the attach the volume to the node. This is also idempotent, so basically meaning that if you make the call with the same volume ID and node ID, it should just return the same results. If it's already attached, then it should just come back and return success. And then this one should be called before the node stage volume and node publish volume. And controller unpublish volume, this is the opposite of the controller publish volume call. It basically just detaches the volume. And so this one should be called after all the node onstage volume and node unpublish is called. The validate volume capabilities. So this one allows the CO to check whether a pre-provisioned volume has the capabilities needed by the CO. So that will return supported if all the capabilities are supported. The snapshot functionality that is new, added to CSI spec. So the create snapshot call is also idempotent. So for some cloud providers, they support uploading, meaning that after the snapshot is cut, it will upload the snapshot somewhere in the cloud. So because we don't want the application to be frozen for a long time, if it was frozen before the snapshotting process starts. So we basically make the create snapshot call blocking until the snapshot is cut. And after that, if the storage system does not support uploading, then it should just return success. If it supports uploading, then it's going to return a gRPC code saying that it's operation pending. So the CO can make this call repeatedly to find out whether the uploading is complete or not. Alternatively, CO can call list snapshots, giving a snapshot ID as a filter, and then that should return a snapshot status. So after the uploading is done, it should become ready. So there are two new controller capabilities, the create delete snapshot and list snapshots. And if a create delete snapshot is supported, in addition to create and delete snapshot functions, the plugin also needs to implement create volume from snapshot, because that's the only way a snapshot can be used. The node service has RPCs for stage, onstage, publish, unpublish, and NodeGetId, NodeGetInfo, and NodeGetCapabilities. So only the stage, onstage volume capability, that's optional. The publish and unpublish is a required functionality. So let's compare node stage volume versus node publish volume. So stage volume meaning mounts a volume to a directory on the node, and publish meaning doing a bind mount, so that make that volume available to a pod. The node stage call is per node per volume, and the node publish call is per volume per workload. And the workload is a pod in Kubernetes. So I first would call ControllerPublishVolume to make the volume attached to the node, and then call node stage volume once. That will mount that volume to a directory on the node, and then node publish may be called multiple times, depending on whether you have multiple workloads or not. And after that, node unpublish, node unstage, and controller unpublish. So node publish volume, basically this one takes the volume ID and publish info, and if the publish and unpublish volume controller capability is supported, then this node publish volume info should be called after the controller publish volume. And this call is also idempotent, meaning that if you make the call with the same parameters, it should give you the same result. So if you call it after it's already published, it should just return success. And node unpublish is the opposite of node publish. And node stage volume. So this one is a optional capability. So this one will be called after the controller publish volume, but before the node publish volume. So this is also idempotent. In node onstage volume, this is the opposite of the node stage volume. Basically, it's just unmounts the volume from the node. So there is a NodeGetId RPC that returns a string, which is a node ID that can be recognized by the plugin. So that is corresponding to a Kubernetes node name, and then that will be used by ControllerPublishVolume. So because it's a string, it's limited. If we want to add more information to it, we can't really expand that string. So that's why now we have a new NodeGetInfo RPC. The NodeGet ID will be deprecated, and NodeGetInfo returns the node ID and also returns the maximum volume per node, so that it tells you what's the maximum number of volumes can be attached to the node. And for the identity service, there are 3 RPCs: the GetPluginInfo, GetPluginCapabilities, and probe. The GetPluginInfo just returns the name and version for the plugin, and also there is an optional manifest field that is opaque for the CO, but the plugin understands how to use that. And GetPluginCapabilities allows the CO to find out whether the plugin implements the controller RPCs or not. If not, it will just won't invoke that. So usually, the plugin should implement both the controller and node capabilities, but in some cases, for example, the NFS CSI plugin, right now, it only implemented the node capabilities. And the probe RPC, basically, that's just tells you whether the plugin is healthy or not. If it's not healthy, the CO may try to bring the plugin to a healthy state. So there are other planned CSI features, such as volume expansion that increase the volume size, topology support. Basically, we'll add some information about the zone and the region so that the CO knows where to schedule the volume provisioning. Volume usage metrics, that is to expose those volume matrix through Prometheus. So Kubernetes has a CSI alpha support in version 1.9 and beta support in version 1.10. And Mesos also has experimental implementation of CSI. Cloud Foundry also has a POC driver. Docker is planning to implement one as well. So for the CSI releases, the first release was 0.1 at the end of last year, and the second release, 0.2, was out in February this year. So the release schedule is every 3 months. So the next release actually is due next Monday.
Okay, I will continue to introduce the Kubernetes implementation in Kubernetes. The recommended deployment Kubernetes offered is like this. The main changes happen on the workload. For the stateful set, there are 3 key points. First, there are 3 different containers running in this stateful set that are external attacher, external provisioner, and the CSI driver. External attacher is used to attach or detach volume, and the external provisioner is used to dynamically deploy, provision volume. And the CSI driver is will start its controller service to help realizing these functions. And second, CSI driver will communicate with external attacher and the external provisioner through the gRPC, which is built on an empty DR volume. And last, the replication will set to 1 to ensure that there is only one instance of stable set is running at once. That means there is no multiple external attacher and external provisioner in the cluster. For the daemon set pod, there are also 3 key points. First, there are 2 different containers running in this pod. That is CSI help containers and CSI drivers. CSI help containers is responsible for registering Unix domain socket with Kubernetes, and the CSI driver is used to mount or unmount volumes for other containers. Second, there are 2 communication channels to be set up. That is Kubernetes to CSI help containers and Kubernetes to CSI drivers. All these channels are were built on a host path volume. And the last, the daemon pod will start on each workload, but stateful set will run on only one workload. Kubernetes team has implemented all these help containers. You can visit this website to get their repository. Okay.
So for the CSI driver for Cinder, right now the implementation is based on the Cinder, the cloud provider version. So for this one, you will need to have a node plugin pod deployed on every node. And then there's a controller plugin pod that should be just have 1 instance running. So that includes the provisioner and attacher. So the CreateVolume basically just calls Cinder to create a volume, and ControllerPublishVolume just calls Nova to attach the volume to the node. For the node plugins, basically the node publish just mounts the volume, and node unpublish just unmounts the volume. So here's some example YAML file. We have a storage class YAML file. There we specify the CSI Cinder plugin as the provisioner. And then we have a persistent volume claim YAML file that just specifies the storage class name as the CSI Cinder plugin. And then on the right-hand side, we have this NGINX YAML file. So here we specify the persistent volume claim and as this CSI PVC Cinder plugin that we created using this YAML file on the left-hand side. And then we also specify the mount path. So after calling kubectl with this YAML file, we should have a NGINX app running with a Cinder volume provisioned and then that will be mounted at the specified location.
Okay. I will show you a demo to how to use the CSI driver. This demo is run on Huawei Cloud, whose APIs are compatible with OpenStack. Here it will get the virtual machines EIP, and we'll use this EIP to install the Kubernetes cluster. Here it will use the CSI driver based on sender to install the CSI driver. It will deploy the Kubernetes cluster and CSI driver following the instructions. Now it starts Kubernetes cluster. Now the Kubernetes cluster is starts. Now it starts the CSI driver. It will start the external provisioner, external attacher, and the CSI driver. It will run this YAML file to start them. Okay, these containers are running. It includes attacher, provisioner, and the CSI driver. You can see the stateful set and the dim set are all running. So you can see there is no storage class, PVC or PV on the cluster, on the Kubernetes cluster. It will continue. It will about to create a new. It will use this YAML file to create storage class PVC, and will start a pod named NGX, which will create a volume. The volume will be bound to URL shell NGX. Now it will use the Kube control to start this pod. Yeah, you can see these containers, attacher, provider are all running, and also the Nginx, which was created right now. It around 17 seconds. Yeah, the storage class is created. And also the PVC. On the console, we will see the new created PV. The PV is attached to DV. Yeah, PV is created. Now the port of Nginx is started. We attach to it, and we see the new volume. Now we write a string to that directory. Okay, we exit. We see the Nginx is running very well. Its IP is 172.17.0.5. And we will access this. We will access its IP to download the string we wrote before. Yeah, it's a success. Yeah, thank you, watch. Yeah.
Any questions? Reference, those are just references, that's okay.
Okay, that's all. Thank you.
Thank you.